Well, thanks a lot for showing interest in this course. I'm really hoping you'll get a lot out of it. It's Introduction to Markov Chain Monte Carlo. Now, I don't know if you know what Markov Chain Monte Carlo is. So I'll just briefly explain it and then I'll give an example. So a Markov chain is a process, a mathematical process, where a new value depends only on the previous value. A Monte Carlo is a generic term to mean randomness and obviously comes from gambling. Therefore, Markov Chain Monte Carlo is a probabilistic system to solve mathematical problems by using updated values based on previous values. In its sense, it's pretty straightforward. The course itself is done in Excel. You don't have to be a VBA programmer, but if you are a VBA programmer, you might be interested in the course simply for the purpose of understanding animations or the power of animations in providing courses. So we're just going to track. And we see that this particle moves within this shape randomly. Its movement depends on the previous value. It's not going a huge distance away. So that's random movement, and it's actually an example of what's called Gibbs sampling. Now, if we return to the PowerPoint, typically Markov Chain Monte Carlo is explained using what's called a transition probability, and that's what we saw before. The probability of going from one x value to another using only its local value. It's not really known much, or at least it's hard to understand by looking at the internet, but in fact, Markov Chain Monte Carlo can be applied to probabilities that are not transitional. That is, the new value of x does not depend on an old value of x. This type of approach, we combine the transition approach and this main probability approach to create a combined probability, which then is a transition probability. And that's the role of what's called Metropolis-Hastings algorithm. I'll just give you an example of the Metropolis-Hastings algorithm. Select here MH. And we track. Now, it's very similar to what I just showed you, but in fact, there's a probability distribution now applied to this shape, and it's favorably going to the areas where there's high probability. You can't really detect it here, but it is explained in the course about this method. And this makes it very powerful for not just problems which are purely Markov chains, but also for problems that are not Markov chains. Because I'm using a graphics type of approach and Excel, the course is very easy to understand. I created the course so it's not in depth. It's not shallow, but it's not in depth. So if you're to read some of the stuff on the internet or in textbooks, you can get confused very quickly. In my course, you don't get confused, and you should have sufficient understanding that you can read the more complex texts and understand now what they mean. So it provides an overview of some applications. This really isn't an applications course. It's just an introduction to Markov Chain Monte Carlo, so that if you were to see an application, you would understand what is happening. So who are the target participants? Well, of course you are, but I'll be more precise. Someone who actually wants to know what is it that people are talking about when they say Markov Chain Monte Carlo, and they don't want to spend 40 hours trying to figure it out. The course goes for about 2 hours. You might figure it all out in an hour. Someone who will be enrolling in a Markov Chain Monte Carlo course and wants an unfair advantage. They're going to understand it much quicker than their colleagues, and I would hope they would top the course. An Excel developer who wants to see how to effectively use animations in Excel. I don't go into the VBA much, but if you are a VBA person, developer, you can now see what can be done in Excel. Markov Chain Monte Carlo is a prerequisite to a number of machine learning algorithms. So someone interested in machine learning could possibly be interested in this course, but there are so many different approaches in machine learning that this is focusing on a subset. Now, again, I'm not going into machine learning in this course. Now, I'm a mineral processor. I use Markov Chain Monte Carlo in mineral processing problems. So a mineral processor may enroll in this course if they're going to later do some of my mineral processing courses. Now, the immediate follow-up from this course is to apply Markov Chain Monte Carlo to the game Mastermind. That's a separate course, yet this is, I wouldn't say prerequisite, because the use of Markov Chain Monte Carlo in Mastermind is fairly straightforward, but it helps. And I don't want to talk too much about Markov Chain Monte Carlo when I talk about how to solve the Mastermind game using machine learning. Here's the structure of the course. 5 sections, an introduction, of course, simple Markov Chain Monte Carlo, the Metropolis Hastings algorithm, where we start to use more complex probability functions. By complex, I still mean fairly easy, and then a conclusion. And then there are additional lectures later on. So all up, there's about 18 lectures, and I'm really hoping that I see you there. I've enjoyed creating this course, and I hope you enjoy it as well.